that I also did this with containers, that it's better because of startup times, that it's so faster, and because it's so easy, because it's Docker compatible. So what I'm showing right now is an end-to-end solution. Of course, the logic part is a simulation of the real logic that I implemented over time, okay? But the process is create something that is CPU consuming and a messaging system that needs to process many messages of that type, okay? And containers that processes that messages to empty the queue, okay? The focus is on the scalable techniques that I will show you, especially on Azure with a service that is called Azure Container Instances. Okay, this is like a Docker as a service for what I learned about it. Okay, so in my opinion, there are some heavy workloads in our application that can be CPU intensive, memory intensive, GPU also, because if you deal with some complex calculation, if you have a data scientist in your team, you will probably know that he or she will use GPUs to process faster his calculation, okay? In this scenario of today, I'm dealing with a CPU-intensive operation. So think about that. You need to process a document. Okay, so you have thousands of documents that arrive to your platform, to your application, and you need one by one to process them, to extract some information, to store the information that you took into a database or something like that. Okay, this operation for each document. So I'm just supposing that in this example, my logic, my business logic, my CPU intensive logic, it takes about 1 second, 1 CPU second. Okay, what does it mean? It does mean that if you have a single CPU machine for 100 messages, you will take around 100 seconds, of course. But if you have many machines, or like in this session, many containers running on the cloud on different machines, of course, with their own resources inside it, you can scale. So you can do the work in just 1 second, probably, okay? So we are going to not implement, because we have not so much time, but I will show you the code that is very simple. A solution that produces some messages and consumes some messages, okay? And as I said, one message will take about 1 second to be processed, okay? I will use the Visual Studio, that is .NET platform, but it's not really necessary to know anything about that. It's just for reference purposes, so it's just a few lines of code, okay? Just to summarize the end-to-end scenario. It's not really needed that you know Visual Studio or .NET programming languages, okay? Also, I will create a service bus that is a broker, okay, a message broker that is completely managed on the Microsoft Azure platform. Okay, so if you are common with messaging system, you will probably use RabbitMQ, or even the service bus or other messaging techniques. Okay, the service bus is the messaging service offered by Microsoft through Microsoft Azure. Okay, so the first things I'm doing is creating the service bus, because it's take about 1 minute, something like that. So I'm just creating the ContainerDays 2021 in Western Europe with this price point that it's not really necessary to depend in the session. Okay. In the meantime, I will show you the code that we have for the producer task. We are connecting to a service bus, to a specific queue that we're going to create in a minute. And for this 10 iterations, I will enqueuing something like 3,000 messages, okay? Of course, they are all the same. Okay, they are just Git GUID, so they're not really real world. Okay, in this case, at the other side we have the consumer task that will connect the same service bus and will process one by one the message. So when a message arrives, that means that a message is dequeued from the queue. This is the code that will execute. So I'm writing a line and I'm waiting for 1 second. So in real world, let's suppose that here stays the logic. That takes 1 second, 2 seconds, 1 minute, okay, and so on. Oh, well, I forgot. Feel free to write your questions in the chat of this Google Meet, okay? I have a second screen so I can see you in real time what you are writing, and I can answer your question, of course. Okay, so feel free to write it anywhere, anytime. Okay, so let's see the service bus created. Let's take the connection string. This is the root connection string. Doesn't matter for the demo. Of course, in real world scenario, you should add some specific policies to read, write, and something like that. But it's for speed. I will use the root key, and that's all. So this is the service bus name, the root key, and this is a key that I'm going to create. I can also call it items. If you are familiar with messaging, this is pretty straightforward. If not, think about a queue as a first in, first out queues. So you put messages into the queue. You or many actors can put messages into a queue, and many actors can read messages from that queue. Of course, just one reader can read that message in a given time. Okay, so there are a lot of concepts to say about messaging techniques and message brokers, but we don't have so much time to deep dive it. So just think about the very, very simple queue that you have in mind, the one in which you put a message and you can take a message out. So in this case, we create the queue inside the service bus account, and I will play the first producer task that is here. That is sending 3,000 messages, second batch, third batch. Let's wait just another batch, and that's okay. I think that approximately 10,000 messages could be okay for this demo. Okay, so if we go here, we will see that we have, okay, 9,000 messages. Okay, at the other side, the consumer will take the messages out with a rate of 1 per second, because we simulated the think time just with sleep, okay, with the thread sleep. So for each second, we have a message processed, and of course, the online queue will decrement its count, okay, in this at this rate. So it will take about 9,000 seconds, of course. Okay, so now this was the introduction, okay, just to give you some context of a sample application that can simulate a real-world scenario. Now, let's Dockerize this app, this consumer app, to put the Docker image into a container registry on Azure, and then use it through this service that is called Azure Container Instances. So let's create. We have a lot of ways to put a Docker image into an Azure Container Registry, but I'm using the straightforward one that is not really real world. In real world, I'm generating on the fly the Docker files from a DevOps pipeline using Azure DevOps. If you don't know that, it's like the GitHub Actions, it's like, I don't know, Jenkins, whatever. Okay, so In real world, probably the Docker file stays in another place, or will generate it at runtime. The build is generated into the pipeline. In this case, I'm doing this manually, okay, to keep the complexity low and just to focus on what I want to show you. That's container instances. So in this Docker file, I'm just testing some. I'm starting from that image, that's .NET, and I'm starting the CDays consumer DLL that is built from Visual Studio. So this is a tweak. Okay, and when I build all the stuff and I open the solution from Explorer, where is it? Okay, here. Okay, I have the DLL, the dependencies, and the Docker file. Okay, so let's have a test. So Docker build test not. Docker build test not. Okay, it's working, even in the containerized version. Okay, so I stop the container, and now let's go back to Azure to create a registry. I'm creating all the stuff on the fly because I prefer to start from scratch, okay, without any complex dependencies already created, okay, except the code, okay, but the code was very simple, so a few lines of code. So here, see, days 2021, Western Europe, standard pricing, and that's all. Okay. Container registry is something that I'm creating in just a few seconds, so I'm just waiting here. The creation process, okay, created, and I'm enabling the admin user to log in into that. So I'm logging in here, Docker login cdays 21 azure.io. Okay. Now usernames. Okay, good. So I'm just building with the new tag the image, and I'm pushing it. So let's go to the repositories after the push operation is complete. Okay, we have the Docker image pushed into my remote container registry. Okay, so now we are at the turning point. Okay, so we create the ACI, that stands for Azure Container Instances, or instance, of course. And what's that? Okay, so the creation process is very straightforward. I just give a name, consumer, CDays consumer, give you a location, and tell the runtime, which is the image to run, okay, and the target quota of CPUs and memory. I'm just taking one CPU and 1 gigabyte of memory. I think it's quite much, but you can have this upper bounds, okay? I don't need any internet connectivity, or well, inbound internet connectivity for that. Probably I need outbound from the container, of course, and that's okay, and that's already configured. And I can also define a policy in case of failure. So if you have this this job, okay, let's call it job, that should run in a continuous way, okay, in a continuous pattern. For any reason, it stopped for failure, for an exception, something like that, the runtime will restart it if you specify the restart policy on failure. Okay, you can also say always to restart even with the graceful exit of the program, but I don't recommend it. It's something that you probably don't want to have. Why you don't want to have? Because container instances are just built for the time they run. So if they stopped with a graceful reason, you stop also from the billing's perspective. So in my opinion, this restart policy is something that you should think about it and decide what to select. Okay. Well, let's go ahead. And it's creating something. What is creating? Okay, so now let's try to imagine. We don't know exactly, even we Azure MVPs as insiders, we don't know exactly what's under the hood, but we can imagine what's under the hood. As you probably know, with K8s, you can have pods, okay, and you have to manage it, of course, as the entire K8s installation. Okay, in the Azure Container Instances, you don't have any K8s to manage, so I'm just guessing that under the hood there are some Kubernetes instances of Microsoft that have unused space and or dedicated space for this service. And when I run this container instance, I'm just dealing with the image that I need to run, the target CPU and memory, and the rest is up to Azure, up to Microsoft. In this case, we see that the container was started, and from the log, we see that it's running. Okay, we can also connect the container. We can also have some properties, some environment variables, and so on. So, which is the turning point of the service, in my opinion, is that you don't have to manage any Kubernetes cluster, any Kubernetes installation to run this container. Of course, this is a simple approach, okay, just a console application that prints stuff. But as you probably know, with containers, if something runs in your container, it can be also run here. There are some restrictions in terms of quota. So at the time being, you cannot have more than 4 CPUs and 16 GB of RAM per container, okay? And you can have more than like 5 incoming ports through TCP, UDP, and something like that. Okay, so those are some constraints that you should think about it when you think about Azure Container Instances, okay? Good, but we did not end the session yet, because my promise was to scale out this workload with hundreds of containers at the same time. Okay, if we go where? Here to the service bus queue, we will see, of course, that the message count is decreasing. Okay, in a 1 per second rate. Okay, but now I want to boost this process with many containers. So what I need to do, I'm just duplicating this tab. I'm just going to the container instance, and then here I have the template that is a JSON format. It's being called ARM, okay, it's a resource model, something like that, okay. So it describes this deployment, this single deployment in JSON format, okay. So we can take this template and we can go to the templates. Okay, this is the dry run, so I can create a template, my ACI's days template, okay, a description, and let's investigate this template. So this is a parameter. So if I use this template to deploy new stuff, I will need to specify this parameter that is the name of the container. Okay, so let's simplify this name, but it's very, very easy. Okay, so this is the parameter, the default value can be just consumer. Okay. Then with this parameter, the template is telling you that it is gonna create a new container group that is the underlying name of container instances with this name, okay, with this type in this location, starting from this Docker image with this quota of memory and CPUs, and using this registry to pull that image, okay. So one thing is missing here is the password to go there. It's not present here in the template because for security reasons. So you cannot export all the stuff with the password, of course. Okay, so we can go back to the registry, take the key again. Okay. And we can put the password here. But this is complete, of course, as a single instance. What we want to do is a template that will deploy a huge number of instances, and it's preferable that this number of instances is decided by the deployer, not hard-coded here in the template. Okay, so what we can do with the ARM template, we can specify a copy directive, and in this copy directive that is called ACI copy, okay, we can say how many times this template will be applied. So the count is like 100, but I want it from the parameters. So the parameter can be count, default value like 100, and type is integer. Okay. So now here we can say take the count from the parameters. Okay. Parameter name count. Okay. And to avoid runtime issues, which ones? If I leave the template at this stage, it tries to create 100 instances with the same name. So it's a simple issue about naming conflicts. Okay, so I need to name that instances with a index, with a random string, something like that. Okay, I can use the index. Okay, so I can say that the name is the concatenation between the name that I specified above and a number that can be the copy index. Okay. So I close the parentheses, the brackets, and that's all. So this can be read as this. This is a template. Those are the two parameters. This template applies a resource with this copy directive. So in a while in a for loop. Okay. So let's commit it and let's deploy it. During the deployment, I need to specify some locations, resource group, the name, so CDays demo, and the count. I specify the double quotes, but they are not necessary. 100. I can also specify 1000, but I will trigger a quota issue exception, something like that from the Azure side. It's not something really a hard limit. It's like a soft limit that you can increase with the support. So I'm pretty sure that 100 it's okay for this demo. But if you increase that number and you will receive an error, we will probably write to the support to increase your quota, your CPU quota in the subscription. So this is purchase, but it's just the meaning is create. Okay, the deployment is in progress, and as you can see in a few seconds. Okay, good. I made some mistakes. Okay. Okay, should be down case. Okay, I can go to the templates. It's okay. And I can deploy with the name that is lowercase. So CDays consumer. Let's wait. Okay, they are creating. There are 100 in a single operation, in a single deployment operation. I'm pretty sure that we already have some one of them. Okay, like those one, but let's refresh it. Otherwise, we will just wait 1 minute or so. Okay, they are ready. Let's take one at random, and it's the queuing, the messages. So we have right now 100 containers at the same time running, and each one is the queuing the items from the queue in a 1 per second rate. So of course, now we achieved the scalability, and if we see the metrics, the counts, we will notice, of course, that the messages are going down in a real faster way. Okay? So that's all. We saw how to set up a producer-consumer scenario with Service Bus in Azure, and how to publish that code with Docker and in a public registry on Azure, and run the actual application with Azure Container Instances. That, in my opinion, is like containers as a service, something like that. Serverless container, as you can imagine them as serverless, okay? Because we don't deal with any machines, with any K8s installation, something like that. We use the templates to deploy in a single click, in a single shot, 100 containers to achieve huge scalability of processing messages, okay? So that's all, and if you have any question, you can also unmute yourself if you prefer, or you can write them in the messages, in the chat. And thank you very much for being here, and I'm here for you until 5 p.m.